Live. I'll double check as well real quick to make sure. But also, if anyone's already here, you can say hello in the chat. And I know people will be rolling in. Cool. Looks like we are live. But again, if anyone's already watching, say hello in the live chat. And maybe put where you're watching from. It's kind of fun to see where everyone's tuning in from. I'm streaming from Seattle.
Hi, everyone. I'm Rajat. I'm also streaming from the suburbs of Seattle, what we call the East Side out here in the Pacific Northwest.
It is, I feel like most people just say Seattle, but sometimes when you're from Seattle and then you're talking to other people, you're like, well, in this specific region of it.
That's right. Oh, I once got, somebody gave me trouble once when I said I live in Seattle, and they're like, no, you live in U District. And I was like, but like my address says Seattle. Like, can't I say I live in Seattle? It's a neighborhood of Seattle. Come on.
Yeah, I would argue U District is definitely Seattle.
So, yeah,
I feel like that person was wrong. Whoever said that.
Yeah, they certainly wanted to give me trouble.
If people say like Bellevue or something, that's where I feel like maybe you're like, well, that is another city technically, but it's
right.
the Seattle area. So.
Oh, and is it another city? It feels really different than Seattle.
Right. All right, so let's wait just like another minute or so before we really get going here. I'll just do a quick introduction, though, kind of a little bit about what we're going to be doing. So again, if people are tuning in, say hello in the chat. Let us know you can hear us. Also, if you want to put something extra in there, put where you're watching from. Also, maybe a little bit about what you're building or learning, especially if it's around machine learning. And feel free to maybe put questions in there as we go at the end of it if we have time. We'll try to maybe get to one or two of them. But welcome everyone to this Union Fireside Chat. My name is Sage Elliott. I'll be the host for the chat today. And at Union, we build tools around ML orchestration and making data and AI pipelines more robust. You might also know us from our open source Flyte, FLYTE, and Pandera. You can check out everything we're doing at Union.ai. But today's chat isn't about us. We have Rajat from XetHub. Welcome, Rajat. And I guess we can go ahead and get going. Could you provide an introduction and let us know a little bit about your background? And maybe we're going to go deeper into this later, but a little bit about what you're working on and kind of how you got to that point.
Sure. Hi, Sage. Thank you for having me. It's great to talk with you. I will say I like fireside chats. I wish there was a fire. It's particularly cold today in Seattle. Hi, everyone. Thanks for making the time today. I'm looking forward to this conversation. I've been in the industry for over 20 years. The majority of that time has been spent as a software engineer building large-scale systems or distributed systems. Couple highlights. I was on the team that shipped the first version of what's called OneDrive today. And I joined AWS kind of at a formative time in 2010, working on the RDS service from a time when it had zero revenue to the time that it became the number 3 revenue generator in AWS. And that happened all in a year. So it was a pretty fun rocket ship time. But for the last 10 years plus now, over the last 10 years, I've spent over 10 years now working on building systems to support machine learning. And this started in 2013 when I joined a CMU research spin-out as the first employee. That company was called GraphLab, which was then renamed to Dato, and then again to Turi. And by the way, for you startup folks, don't rename every year. It's just not fun to rebuild a brand every year. And Turi was acquired by Apple in 2016. Now, our mission at Apple was pretty simple. We were tasked with building the ML platform for all of Apple to use. There was lots of machine learning happening at Apple in 2016, but each of those teams kind of had to start from scratch. And I mean Mac minis on desks, GPU workstations sitting in closets and in conference rooms. So Apple realized that having some centralized infrastructure could enable machine learning teams to work quickly and to work more efficiently. So the part of the platform that I focused on with my co-founders was the data parts of the ML platform. We got to work with dozens of ML teams over the years. We shipped hundreds, those teams shipped hundreds of ML features. And by the time we were leaving Apple in 2021, the systems we managed had over 100 petabytes of data stored. So we got to see things from the beginning through a pretty big scale. So when my co-founders and I left Apple in 2021 and we started XetHub, our focus was to kind of take what we'd learned, improve upon it, and bring it to a bigger, to more teams. What we'd seen is what ML teams struggled with inside Apple and before, now more and more teams are struggling with. Technical teams need to work on larger and larger projects. They need to work in a distributed fashion, and there just isn't good tooling for that. So our thesis with XetHub is, can we bring the GitHub workflow, which we've all kind of taken for granted as software engineers, but it allows us to collaborate in a distributed way, stay on top of things, experiment freely, and we take that workflow and scale it to the size of ML projects today. So we've scaled XetHub today to 100 terabytes per repo, and in about a month or so, we'll be able to say 100 petabytes per repo. So anyway, that takes you a little bit to where I'm at. These days, as a co-founder of XetHub, I spend most of my time talking with customers and occasionally getting to write some demo code. How's that for an intro, Sage?
That's great. And that's awesome. I can't wait to hear more about XetHub in a little bit too, going from what did you say, 100 gigabytes to, what was it?
100 terabytes to 100 petabytes.
Wow. Yeah, it's already 100 terabytes.
Yes, per repo, 100 terabytes.
Per repo. That's incredible, especially right now with all the large language models and all these really giant models right now that are happening in the space. I think that's very important. That's really exciting.
Yes. Yeah. I think Gen AI is a fantastic, ML is already an interesting domain, and Gen AI on top of ML just like accelerates the challenges involved at size and scale, like just a whole other order of magnitude.
Incredible. Also, I remember when I first moved to Seattle, when it was called Dado, and you had the really cool logo. I think I had a sticker of the Dado dog, at least is what people called it in the meetup. Yeah, exactly. I still might have an old laptop, I think, with that sticker on it. So,
nice.
And then I remember it going to Turi, and then I remember the news about when it got by Apple. That's a really fun journey that you've been on.
Yeah, I mean, look, Seattle startups. I've really, Madrona's been a great partner of ours at XetHub. They were the lead investor in GraphLab, and they've done a fantastic job of investing in Seattle-based startups and sort of fostering this ML ecosystem in Seattle. So anyway, yes, it's been great.
Awesome. All right, so our main topic today is the challenges of building an ML platform. Before we get into the challenges part, maybe we could talk a little bit about what is an ML platform.
Oh, this is a fun question, and it's a big question, and I could go anywhere with this, but I think like you said, let's spend a minute on the requirements of an ML platform. Like, what are the things that, so we're all on the same page as to what an ML platform needs to be. I look at it like this. The ML platform is responsible for enabling machine learning teams to do their work. That means training models, deploying models, or deploying and building ML applications. Maybe I could put it a little bit more formally. An ML platform is the set of services that allows ML teams to focus on applications. These are services that support or enable the machine learning lifecycle or the machine learning workflow. Discovery, experimentation, model development, evaluation, deployment, and operations. So I look at it as an ML platform is the suite of services or products, depending on how you want to talk about them, that support this workflow or this lifecycle.
I think that makes a lot of sense to me. All right. And yeah, I think it's a kind of a big question, I guess, right? Like everyone's ML platform is going to be a little bit different. All right. So what are the challenges of building an ML platform? This is probably even a bigger question, because I think there's a lot of challenges that can go in here. But let's kind of start with, I guess, how you would break it down and then go from there. Like, what are some of the top challenges that that you've encountered and that maybe people should think about?
Yeah, I think so. I want to start going back to the requirements and let's like flesh them out a little bit, because this life cycle, you see diagrams of it everywhere, the ML life cycle, and there's all, boxes and arrows and boxes and arrows. But what does it really mean if you're thinking from the system builder perspective? What does it mean to have discovery, that stage of the life cycle? What is the platform's responsibility to support the discovery stage, for example? So let's go through each one. So with discovery, can teams find the relevant data sets, models, or projects? And I know this sounds like kind of trivial or like, how could this be a challenge? Like, how can this be a requirement? How is this a thing that we have to talk about? But I've seen it so many times. I'll give you a quick story. When inside Apple, we were building out our platform, and at one point we got connected with the legal organization at Apple, and they told us a story of how there's a really great data set called the Flickr data set. We're getting the Flickr feed. This is years ago, right? A decade ago, you could suck down, you could get API access to Flickr and then use those images. It's a really great data set. It's a great commercial data set. Lots of companies use it. So legal told us that there was a group at Apple that had requested access to this. And since legal reviews all contracts, right? This is a commercial agreement. Legal had come through with, okay, you can use this data set for these reasons. And yes, this contract is fine. They need to approve the contract. And then several months later, that same contract showed up on their desk again. And they were like, wait, what? Didn't Apple already buy this? And it turns out that no. Yes, Apple had already bought it, but another group inside Apple had no idea that this data set already existed. And what that means, like, what does it mean inside a company? Like, what does that mean? Well, it means that the second team that was requesting this data set spent months working on a prototype to prove out and build a business justification for paying for this, working through the different layers of the organization to get to approval. Like, it's not an overnight thing to get approval when you're making a commercial arrangement between two organizations. All those months were spent only for legal, because they're the bottleneck on, like, they review every contract. They're the only ones that noticed, hey, we've already signed this contract, and they stopped it. And suddenly, this is like an example of why discovery is so important. If you can't, it's often, how would I say it? Data sets are incredibly valuable and they're incredibly expensive to build. And so if you're not utilizing them inside your organization by having other teams be able to discover them and interact with them, your platform is failing you. If every team has to go find all of the data sets from the ground up, and I've seen this before where, one team can only work with one type of data and another team doesn't have access to that system and can't use it. And all of this stuff just slows down your work. So discovery becomes this like critical piece, because you can't solve an ML problem. You can't train a model if you can't find the relevant parts to it. So that's the first one. The second one is exploration. And this one, again, sounds silly. I mean, we're so used to just being able to like watch a preview of something or watch like a trailer of something or watch the 30-second like summary of something. And especially with LLMs, let's just throw the thing off to it and have it summarize it for us, right? Like we're kind of like, spoiled in many ways to like just expect that you can understand what's going on inside a big project. But that's not the case. If you have a terabyte data set or even 100 gigabyte data set, how quickly can you figure out if it's useful for you? You look at a README file. Does it tell you exactly what things look like? Sometimes it doesn't. Sometimes it's the right type of data. Oh, I want images of birds. This is a bird data set full of images of birds. That's great. But maybe they're all black and white, and that's not going to help you. Or maybe the dimensions of the photos don't actually help you, of the images don't help. How quickly can you explore that thing and see if it's relevant for you? Do you need special permission? Like, do you have, is it like you can't get to that database? You can't get to that lake house. You can't access it. You know it exists, but you can't get there. That's a problem that so many ML platforms have to try and overcome. Are there special APIs? So many data sets and models are sort of trapped behind like, oh, just use this Python API. But that means you have to use that Python API. You can't just go and use the data. There's some like gate, there's some hurdle involved there. Is there something new that the team needs to adopt? Some new workflow, some new component? All this just gets in the way. You're still just trying to figure out, does this data set or does this model apply to what I'm trying to do? So that's like the challenge or the problem with exploration. Now, the part that everyone talks about a lot, and I don't have to spend a lot of time on is model development or experimentation. This is the part that there's an endless amount of content about model development and experimentation. This is the actual act of training models, evaluating, not just evaluating them, but seeing how well they run, making sure you can try different experiments, trying things quickly. How quickly can you iterate? It's a core requirement of every platform. I don't think anyone's going to argue but I do think there's a couple pieces of this that are worth zooming in on. One of them that's really important as the platform builder is the utilization of your shared resources. So for most organizations, that's their GPUs. That's where there's a really small number of them and everybody wants them. So how well are they utilized? It's one thing if you have thousands of people using your cluster, but if every one of them has to wait days to get their jobs launched or have their pipelines run, and those GPUs are at 3 to 5% GPU utilization, I'm not making up that number, that's a real number. That's problematic. You're wasting so much time and money underutilizing your shared resources. So it's important when you're thinking about building an ML platform, it's not just that I can launch pipelines or the platform enables launching pipelines and running things quickly, getting code running quickly. It's how quickly can a team embrace the platform and adopt it? And then how efficient is that platform? How efficient is the platform at utilizing the resources it's built on? The next stage of the ML lifecycle is the evaluation stage. And this one's often like trapped in with experimentation. And the reason I want to pull it out is, yes, you are doing evaluations on each model that you're training, but the idea of an evaluation phase, the way I've seen it, the reason I think it's a requirement for the platform is, I guess the way I want to describe this is, what is your model going into? What is it a part of? The model in and of itself, unless it's a research paper, is not the artifact. It's not the thing that you're working on. You're working on Face ID, which is designed to identify your face using a 30,000 point 3D point cloud at 60 frames per second with 6 ML models working simultaneously in real time to do that identification. So you're working on Face ID, but you're training one of these 6 models. So what is the evaluation lifecycle phase? The part that I want to highlight is your model has to go into something, whether it's deployed as a service, whether it's used in batch inference. So you have stakeholders outside of the machine learning team that need to know that things are going on track, things are ahead of schedule, there's areas that need more investment. And that's the part I want to call out for the evaluation phase. Can everyone, especially leadership, follow along as models are being evaluated? I mentioned this Face ID thing. Everything I've said was announced when Face ID launched. There's 6 models. And that meant there were 6 different ML teams, each working on these models. And the leadership of the organization had to know, Well, this is the big announcement for 2017. The iPhone 10 is launching with Face ID as its flagship feature. And Apple parlance, these are called tent poles. It's the tentpole feature for that product launch. Apple had been working on Face ID for over 4 years leading up to 2017. We joined Apple in 2016. I know exactly how far the software was for shipping. And it's really hard to know if these 6 models are going to get to a high enough accuracy standpoint, be effective enough, fast enough on launch date. And that's where evaluation becomes really important. If your platform is not enabling organizations to understand how the ML models are progressing, then it's not meeting its needs. It's going to be a sort of thing that will keep coming back to you.
And that's got to be even more interesting potentially right now with the whole Gen AI space and everybody wanting AI right now, right?
Yes. I mean, if you want to talk about constrained shared resources and everybody wanting something in production today, first of all, these giant models, they need huge GPUs, huge GPUs. And so you have even fewer of them, lots of GPU RAM, and then you need lots of them simultaneously just to load the model. And then your quality control for these apps is so much harder because there's so many more moving parts. The large language models or the foundation models themselves keep evolving. Your embeddings keep changing. And the embeddings, at least from my experience, they're orders of magnitude greater than your source data, depending on how you generate your embeddings. So the scale of your data also exponentially increases for Gen AI and running the models and doing it all at the same time. And oh boy, your training environment, now your production environment, oftentimes your training environment can be your R&D environment, can be beefier. And then you go through an optimization step to get the model smaller and then deploy it. But you can't do that with Gen AI because the darn foundation models are so large. So it really sort of even further makes this evaluation step harder because you need more resources to evaluate, you need more resources to train. It's a pain. This bleeds into my next one, which is around deployment. Everybody thinks deployment's kind of a solved problem, even though ML ops is new and it's an extension of DevOps. But everyone thinks it's just, it's this deployment, no big deal. Yeah, but it actually can be in a couple of really important ways. And we touched on one of them just now, where Gen AI models need so many system resources to run that you actually have to think about that, like when you're designing. And so I saw the opposite end of this because so many of Apple's ML models run on device. They don't run in the cloud. They run in your hand and your phone. So you have to think the opposite way. Okay, whatever I'm training, maybe I have a big, powerful GPU to help me, but then I've got to get that model down so it can run on the GPU on the device. And so your deployment environment is like, how well does your platform enable the ML team to test their work in the environment that it's going to run in? And so that, does the practitioner need to know? And is deployment of your ML model different than a software deployment? Many times it can be, many times it doesn't have to be, but you absolutely have to think that through. It's not solved unless you do that. Okay, and the last one, operations, or the running of your ML models in applications. Here, I just want to zoom in on the requirement that debuggability matters. Every team that has taken a model to production, you should ask them, I've asked them, what percentage of their time do they spend debugging something that's gone wrong? And it's unfortunately often 25% of a given month. So 1 week out of the month is eaten up in debugging because some pipeline broke and there's so many pipelines involved. And then you're having to chase back what happened, what changed. So your platform has this requirement to, I believe, to enable this debugging cycle. Because if you shouldn't, your ML team should not be spending 25% of their time trying to figure out what went wrong. It's often some, data dependency that's changed slightly. And so 3 steps up in the pipeline, something broke. Almost all teams just rerun their pipeline when a pipeline fails because they're like, well, there's a lot of steps. I don't know. We'll just run it again, see if it fails again. And again, it's this time and energy that's spent. Okay, so those are the requirements, right? The areas, the life cycle stages. We haven't even talked about the challenges yet. So
right, I'm sure each one of these has their own big set of challenges in there as well.
But I thought I would so look, these are requirements. These are hard to do. I'm not going to say it's easy to do any of those things, but assuming that you're already thinking about those, what are the sort of my top 5 challenges from building the ML platform, not only at Apple, but also from the ML platform teams I've worked with over the years? I think there's 5 of them. They're somewhat controversial, maybe not. But I think that this is why I want to bring them up, because I don't think they get talked about enough. The first one, and there's a lot of ways to phrase this. I'm going to phrase it: don't underestimate the edge. As systems builders, we often like to think about back-end systems and scale and servers, but like the dirty secret about machine learning has not changed. 80% of it, and I think I think it's likely even higher than that. 80% of ML is happening on a laptop. It's happening on a local machine. So it's that part of the edge. That's what I mean by the edge. So the challenge for an ML platform is making sure it can cater to the edge effectively. Because if you're not, and you're asking everyone to work in the cloud and work in a cloud native way, you are really asking the ML practitioners to work with less tools that they're used to. There is the familiarity of the workflow that you have, and it's really hard to adjust that. And frankly, I think, one of the ways I describe this is, ML teams are doing really challenging work. They've been asked to find if there is signal in this pile of data that can predict something. That's really hard to do. You don't know going into it. You don't even know if you have the right pile of data. You're finding a needle in a haystack, but you don't know if this is the right haystack, and you don't know if there's a needle, and then you don't know if that needle's sharp enough, on and on. So asking that same group to say, hey, by the way, let me just give you these like limited tools that only work in the browser in a certain way, that that's all you have to work with. It's just making what's already a really difficult task even harder. So don't underestimate the edge, the importance of supporting the edge in your ML platform. And of course, calling it the edge also helps in the deployment case, because more and more ML needs to run in smaller and smaller places. And so you have to think about those things.
Yeah, and I'm sure we're going to see more and more of this coming to like phones, for example, like you've mentioned, I think a couple of times, like iPhone, Android, everything now, or almost every chip that's coming out now that I see in a phone or a computer, they all have an NPU on them. Like yep. we're gearing up for this, right? Like there's going to be so much AI at the edge, or whatever you want to call it, like on people's hardware and silicon that like you have in your hands.
Exactly. What was that? I'm just watching MLC chat using like one of the Olama models on an Android phone in real time. Like that's been really fun to watch. Another Seattle company, Octo.ai, has been putting out some good videos on. I think I've been watching them on LinkedIn. It's been really like, yeah. I mean, it's the only thing holding it back is like, again, the devices need to be a little bit beefier, and the drop off point for an LLM from being incredibly useful to being really not useful at all it's pretty apparent. So you don't want, but we're almost there. So yes, exactly. The edge matters. The next challenge I've got, and I think this one maybe is the most controversial, but I'm going to throw it out there, and I'm curious what you think, Sage. Here's the claim. It's all unstructured, or at least increasingly unstructured. So what I mean by this is the vast majority of data systems over the last 40 years have focused on structured data. How well can we structure it? How well can we understand that structure? How efficiently can we store things that are structured? I mean, this has been the area. This is how data has been managed for decades. But ML data, and increasingly, especially with Gen AI, it's all unstructured data. By the time the model sees it, it's unstructured. The model doesn't understand the structure in the data. It's just seeing data. So your ML platform, go ahead.
Oh, sorry. For anyone, like, let's say they were new to machine learning, what's the difference between structured data and unstructured data?
Yeah, it's a good question. So I don't have like a great definition. So my definition is the following. Structured data is data that has a relationship where it's your interaction with that data leverages that relationship. So you can think of relational databases where you have a customer table, an orders table, and there you can join between them. So you're not, so you can say for this order, it has this customer ID. So the orders table has a customer ID column, and then the customers table as a customer ID column along with the rest of the customer info. That's like a classic type of structured data. I'll even go further to say your NoSQL stores are still structured because you are querying them a specific way. So even if it's a key value store, you're rarely throwing arbitrary data into. It's likely the document is a JSON object or an XML object. It's a well-structured object that has an identifier that's your key. So I put all of that into the structured category, including the new, it's not new, but the new interest in things like graphs to leverage relationships between entities. All of that stuff is structured. It's where you can take advantage of the structure, not only in storage, but in querying and in understanding the data itself. Unstructured data is everything else. It's a pile of images of birds. It's all the videos that you've captured on your phone. There's no structure to that data. It's just a collection of things. And so, as you can imagine, or as you've seen, as deep learning has taken the ML world by storm, it's more and more unstructured data. Especially, even if it starts as structured data, by the time your model sees it, it's unstructured. And so your ML platform has to think about unstructured data and work well with it, especially if you're building for Gen AI. Like, it's all unstructured in Gen AI. So that's what I mean by that. How's that answer for the difference between structured and unstructured?
I think that's pretty good. I always like to use images as a good unstructured example too. Like, it's a whole bunch of pixels, right, that is in the data set really, and you're trying to figure out how those relate together versus having something that you can easily kind of query, as well as an example, or the example I often use, I think, as well.
Yeah, I think another way to say it, the other example is like, can I get statistics on the thing? If getting statistics means executing a compute job, then it's probably unstructured. Whereas if it's structured, getting statistics on it, count the number of rows that does this, what's the average of that's usually structured data. So kind of as a follow-on to this, but I've pulled it out separately specifically because it's this important. And this is also a similar in controversy, but the challenge is that it's files. Everything your platform works with, it's all just files. And the thing I want to highlight here is the ML platform, to be successful, it needs to support the broadest range of tools and frameworks. You can't be a successful platform if you say, well, I only work with this version of this framework, because there's a really good chance that in your organization over time, maybe on the day you launch your platform, that's all that's needed. But in 6 months, there's going to be a new ask where, oh, well, I bet an ML model could help here. And the way you want to go and build that model is likely using a different framework. So each of the frameworks has different strengths. Each of the frameworks get applied for different applications or use cases. Your platform's got to be agnostic to all of it. And the one thing, the lowest common denominator, the one thing that all frameworks and all tools know how to use They know how to use files. It's just files. The file system is the lowest common denominator. Everything else you can add over time if you need to, more as an optimization, but your platform better work well with files.
It's all really just ones and zeros when you boil it down. and those are saved as files.
Exactly. I mean, I think this is the funny thing, right? It's, so much of what we do in computing today has been around for 50 years, and it hasn't changed. And so this idea that, we should do it a new way, as a platform builder, you kind of want it's like a lot of software engineering design. You want it to have well-defined abstractions and modular abstractions so that you can optimize where you want to, but you should not start with an optimization. You should start with something that has broad appeal, broad reach. And what I've learned is file system is king. Anything else is just not as widely adopted or as widely supported. So look, everyone's got to say scale is a challenge, right? I mean, this is like if you don't think scale is a challenge, then, I'm curious what sort of ML platform you're building, because ML is amazing. It pushes compute. As someone who cares about distributed systems, I love machine learning. This is why I've been at this for 10 years, because nothing pushes compute and storage and network for nothing challenges your distributed systems like machine learning. But I want to say the challenge for scale in ML, the one that's under discussed and underrepresented, or not underrepresented, but just not talked about enough, is this one. The IO pattern. So your IO cost for machine learning is very high. I talked about GPU utilization earlier. That's because the machine is sitting idle waiting for data to download. That's an IO problem. So the IO pattern for ML is different than all other data processing previously. And the data systems are not designed for ML workloads. So this is why I say scale is actually an access pattern problem. So traditional data systems have focused on sequential data processing. It was always like the disk is really slow, so I better orient everything. The spinning disk, the actual hard disk that spins, right? I don't know if you were familiar with these, Sage, but this.
I remember those days.
Okay, yeah. So the spinning disk thing is real. So anyway, the sequential writes were really what everything was optimized for, because you had to get it all on disk. But that's like, but that's not ML. The IO pattern for ML is random IO. And this is especially problematic because disks are not designed for doing this efficiently. So if you're relying on sort of legacy storage systems, you are making the challenge for ML even harder, because it's gonna be slow. And so, yeah, that's where I think you've got your platform. The challenge here is thinking through, does the workload that ML offers apply? And the last one, and this one's a pretty, I think this one's a more recent one. 10 years ago, when we joined Apple in 2016, this wasn't the problem. This wasn't a challenge. And the challenge is, like, there's a lot of tools out there in this space. So if you're trying to build an ML platform, there are a lot of tools there's a lot of tools you can choose from. It's a really fragmented space, and everybody says something. And so the challenge here is, at least the way I'd look at it, building a platform today, that the challenge I'd say is, know what you want to innovate on. And I'll give a simple example. Don't build an orchestration layer. I have seen multiple efforts at this. Each one of them is just, it sounds so much fun to write. I mean, who wouldn't want to write another one? But then when you actually go to run it and operate it and scale it and extend it, it just becomes the thing you end up focusing on, which is likely not the key piece of your overall platform. So just use Flight, and move on. Extend it, contribute back to the community. Honestly, just don't go build a piece unless you really want to make that your area of innovation. So I call that challenge like pick your poison. There's a lot of things out there. Pick the thing you want to really innovate on, and don't I certainly don't write an orchestration layer from scratch.
Yeah, like you said, you can use open source one like Flight, the one that we manage. And we had a really cool example. I think we published it last week where LinkedIn was using Flight, and they switched, I think, all their large language models to using Flight or their workloads. And they had a really cool feature they wanted, and we built it together and put it in the open source. So
Nice.
just, if there isn't something there that you need in that open source orchestrator, you can make it happen, or we can make it happen, which is a really cool example. Just like you were saying, you don't have to build everything from scratch to probably get the thing you want. There's going to be a good open source tool for it, hopefully, and then you can maybe contribute that feature you want to it.
So let's see. Yeah, I think that's what I wanted to say. 5 challenges. I'll sum them up real fast. Don't underestimate the edge. It's all unstructured. It's all files. Scale is an access pattern problem, and pick your poison. Those are the 5 I would highlight today.
Awesome, and super in-depth answer. So thank you so much. I'm sure people hopefully learned a lot from that. I know that was an awesome answer. I wasn't expecting necessarily so in-depth, and so thank you. That was really, really cool. What's the biggest challenge you personally faced when you were building an ML platform? Was it one of these? And how did you overcome it?
Yeah, it's a great interview question, Sage. I hope I get the job. The challenges I mentioned come from my experience, and I'll try and summarize this pretty quickly. We built a product inside Apple. We wrote a paper about it and published it in SIGMOD in 2019 called, the paper was titled Data Platform for Machine Learning. And so the paper talks about the system we built. And in that system, we thought we were being incredibly clever. We were doing data set management. And so we had 3 main objects: the data set object, an annotation object, and a split object. And again, I told you about the discovery challenge and making sure you can reuse data sets that are valuable, so different teams can use them. So we wanted every team to be able to work off of a data set object, but maybe put their own labels on it with the annotation objects, or maybe put their own engineered features off of it. And we wanted them to be able to create their own splits, and splits are row-wise materialization of query results. Think of it as train, test, validation. You want to split your data set, but you don't really want to make the data set itself split, because then other people have to work off of the splits you've made. You want to be able to record your splits separately. And so this sounds great in like a structured relational way. You have 3 tables. Each data set comes with a table, which has an ID column, and then annotations have a foreign key to that ID, and the splits are just tables that have ID columns. And now each one of these objects is immutable and independently versioned, and teams can share and run. And it sounds so beautiful. But in reality, this was just all friction. Every ML team was like, just give me files. And of course, the data set was a table and a bunch of files. So no one used the table, everyone just used the files. And it was like a very sort of, it was a harsh lesson to have like a beautiful design and then watch it not get used for all the right reasons. Like, this wasn't actually enabling the ML team. It looked cute and it looked nice, but it didn't actually make the job easier. So I think that's the challenge that I personally faced, was designing a thing that I was proud of, thinking it was going to make things better, and then watching it not make things better. And trying to change ML teams' workflow. Again, that needle in the haystack problem. Don't make the problem they're solving is already hard enough. Don't make it harder by introducing new concepts into the workflow.
Yeah, I think that's a very common problem too, where people create something thinking it's solving the right problem, and then they end up it's not. And it's a hard thing to fix, because everyone goes through this, or most people, right? You're going to encounter something like this at some point. And yeah, it's just like the best way is to communicate more around as you're building stuff and having people try out iterations potentially, right? And they go, oh, why would I do this? And
Well, then you've got to, you've got to be humble enough to listen.
yeah,
Like,
yep.
But yeah, I completely agree. I think that, it's the other challenge I think a lot of ML organizations face today is there's just a lot of constraints on resources, whether that's people and teams or systems. And so how do you operate within those constraints? Personally, I have to say inside Apple, we didn't face this. Apple made great investments in systems and in people. And so that wasn't a challenge, but outside of Apple, I've seen this over and over again. This is a constant, it's difficult to navigate this.
And your next interview question is going to be, can you reverse this linked list?
Oh, I love it. That's a good one. I probably can still pull that off. Reversing. Oh, this is good. Yeah, I can do a reverse linked list. I can't do the more complex things, but I can probably pull that off.
But
Don't
you have
ask
to
me the math stack problem.
keep big O notation in mind. You're not going to brute force this. You're not going to get the job.
I love it. It's so great. Some of these interview questions. It's amazing how informative they are, even after the solutions have been well known for like 30, 40 years. It's still like asking someone to walk through how to do a simple problem and explain it to you, even if they know how. Super informative.
Even if they don't know how. I think that's also super informative, right? Especially if you're this is a little off topic of our thing, but especially if you're hiring someone a little bit more junior or something, and if they're instead of them freezing up necessarily, be like, no, I can't do this, and they're asking the right questions of how would I do this, and they're like, hungry for that knowledge and teachable, like that also is a good indication, right?
Super valuable. I mean, I really think the whole the interview process it should be less about being a performance where it's like, do you know your lines when you get up on stage? It shouldn't be like that. It should be a collaboration where, as much as possible, in the time you have with the candidate, or both parties really should get a chance to understand what's it like to work with the other person.
Yeah.
And I mean, you're never asked. I mean, my whole career, right? 20 plus years now, I've never been asked to solve a problem that I was asked in an interview. Right? The problems are always harder and more ambiguous and more more difficult. And you never solve them alone.
Right.
And so it feels that part of the interview thing always felt performative to me, not instructive. So as much as possible, at XetHub, we do a take-home project, and then we kind of do a discussion through the implementation. That's one of the ways. And then the rest of the interview process is behavioral questions. So much like, tell me about a challenging system you've worked on and how you overcame it, like that.
Yeah. Speaking of XetHub, because I feel like we could talk probably another 45 minutes on interviewing and how we can potentially make that better. But instead, could you tell us more about what XetHub is doing? And like how people would use it. We just talked a lot about all these challenges. How does XetHub kind of help with those?
Yeah, it's a good so I think our approach in XetHub is really the idea that, and it's a cliche at this point, but data is the key ingredient to ML success. And so we think of XetHub as being the tooling that integrates your data platform into your ML platform. So a way to think of this is all the limitations that I mentioned around scale and the IO pattern that ML, the differences in that IO pattern, XetHub is built exactly for ML IO, for the IO pattern of machine learning data. Read often, data should be immutable, but we don't want to introduce new frameworks or tools. So XetHub is built using the same paradigm that you're familiar with, using Git and GitHub. So we think of XetHub as the system that enables machine learning teams to have reproducible results that are guaranteed with all the collaboration benefits of the workflow that GitHub offers, and features specifically designed to enable ML teams. This is around visual context. It's hugely important in ML. imagine you have 10 gigabytes of data files and they're changing every day. How do you reason about those changes in a way that's quick and easy? And so that's custom visualization, custom views over your data, watching your data evolve, and understanding how it's evolving, understanding how your models evolve. It's taking the repetitive analysis work that often exists in every ML org. New data drop comes. Is it still usable? Does it still fit? And making that a repeatable, continuous integration job so it's not something that someone has to spend time on. I think a simple way to put it, so many ML teams today are sharing results with like screenshots in Slack. Like, let's make that a whole lot simpler for them. And so it's that mindset, but without introducing new tooling. So Python API that's open source, and an extension to Git that's open source. So you can get started. It's a free product. It will look and feel like GitHub, but it scales to 100 terabytes per repo today.
And how much is it going to scale in a couple weeks?
Couple weeks, 100 petabytes. The hardest part is that's like, I don't like saying numbers until we've done some like, experimental results. So the only reason I can say 100 terabytes is because we did some experimental results to give us confidence there. The 100 petabytes is more of a theoretical limit based on our design. I want to see it in practice before I can say, yeah, that's what we have now. But
Gonna have to find someone with that much data to test it out.
I mean, you end up having to like generate tons of synthetic data, which, again, you question how close is it to the real thing and that sort of stuff. But yeah, we're getting, that scale, the thinking for us on the scale side is just, we've got to be one order of magnitude ahead of where people are today, because you never want to introduce or incorporate a system into your platform or into your workflow that, only solves today's problems. Because those problems are changing in a year and the scale is going to change in a couple of years. So we've got to be ahead of that.
So if someone has that much data sitting around, they should reach out to you, which all of your contact info or how to connect with you is in the description. If you're watching this later or watching it live now, reach out to Rajat and test their system out. Do you have, it sounds awesome. I'm really excited to play around with it myself. Do you have, whether it's just a use case or maybe some, like you've seen a company use XetHub before, that's just one of those moments where you're like, I love sharing this story?
I mean, I have several. Let's see. I don't want to tell you all of them. Okay.
And it's okay if, if you can't mention names or something like that. That's
totally fine. So I'll give you one that's where I'll say the name, and I'll give you another where I can't say the name yet, but I will be able to soon. So Gather AI is a very cool ML startup. They're the leading logistics company that uses autonomous drones in warehouses. So they have such a cool ML application. They autonomously fly drones in warehouses, taking pictures, and then using object detection to predict capacity for those warehouses. So this is like, this is replacing a forklift operator spending 8 hours going down up and down the aisles of a warehouse to see how many pallets are available. And so and what I love about Gather AI story is they didn't talk to us at all. They saw a Hacker News post and they just started using us. And it took us a couple months to get their chief scientist to respond, because we wanted to know, like, okay, this is awesome. How's it going? And they've been using us. Their usage has continued to grow. They acquired another company, so they've scaled out to over 25 warehouses now. And it's a really cool application where they dropped 4 different data storage solutions to pick up XetHub. And because of how XetHub's architected our deduplication technology, which is the key piece to why we can scale to 100 terabytes today, that has enabled their deployments to be 40% faster. So that's the one, like, public, not one public, but that is an example of a case study you can read on our website with more details.
That's
but
awesome.
the one that happened last week that I want to share, that I can't share the name, and but it's a use case that I think is so common, where this team doing cutting edge work in biotech, there's ML involved upstream and downstream, meaning they're taking ML results and then they're doing analysis on it, and then they're returning that analysis back to their customer. that team has always struggled with keeping track of all of the parts, the upstream ML data, their code that does the analysis, their notebooks that help them see their results, and then sharing the models that they train to do their analysis, and then sharing those results back to their customers. So they started using XetHub a couple weeks ago, and it was so great to catch up with one of the data scientists who just the comment was, and I don't have it as a quote, but the comment was, it's so I can move so much faster knowing that I can keep everything in one Git repo and never have to think about it. I never worry about, crushing somebody else's data. I never worry about what I did yesterday. Where did it go? Can I get it back? And just having the whole project in one place has been it's accelerated their ability to not only do what they're trying to do, but know that they can forget about the project when it's done because they can always get it back. So that's that's the second story that I think has been really, it's very validating for the work we've been doing over the last couple of years at XetHub to bring this out, to see teams, to hear how teams are leveraging it for their ML problems.
Both of those are awesome, incredible stories. And I love the way you worded, like, oh, my project's going to be there. It's like, before you ever used GitHub, if you're learning programming and then you lost your computer or something happened, you didn't have your code before. But now if you're using GitHub, it's all up there and it's versioned. It makes sense. Like, it's easy. I'm not worried about it. Why don't we have all that with ML projects?
Oh, but we do
well,
now.
we do. Now we do.
Use XetHub. That's all.
Yeah, I think that'll be the question people have in their heads. What? Yeah, why don't I have that right now? Why isn't everything in one spot like that? So I think it's awesome, and I'm excited to build out some examples using XetHub and Flight and Union together. I think will be really awesome, and we also have users in similar spaces like biotech and autonomous vehicles and stuff. So yeah, I think it's going to be really incredible. I'm so excited to see like where this tool goes, where XetHub goes. I think it's in such an awesome space. Before we wrap up, is there anything else you want to shout out? Anything you have going on?
I mean, this is the highlight of my week, Sage. Are you kidding me? Like, this is the highlight of my week. No, I think it's an exciting time. I don't have anything specific to shout out. I would say that if you're in Boston, we're going to be at ODSC East in April. Definitely come and chat with us. And if you have ideas on what we should be giving out as swag, I want to hear from you because we still haven't designed that yet. So, but yeah, it's we're in Seattle. We're in the Fremont neighborhood of Seattle. So if you're ever in Fremont, we're across the street from Fremont Brewery. So let us know. I think the biggest shout out I can give you is to join our Slack community. And I will Sage, I'll send you a link to this so that you can share it on the recording.
Yep. I'll put it in the description. I don't think it's in there right now, but the link to XetHub is in there, and I'm sure you can also find it pretty easily on your website. So if you want to go join the community, I assume you're in that Slack channel. If you would directly want to ask you any questions or share anything, that's probably the place to do it, right?
Exactly. Yep. We'd love to hear from you. We want to hear about the projects you're building. There's so many cool ML applications under development right now, and enabling ML teams to be successful continues to be energizing every day. So I want to hear about what you're working on, and I want to hear if XetHub helps. If it doesn't, I definitely want to hear from you, and I want to know why.
Awesome. Yeah. And I know like your LinkedIn is also linked below. So if people want to connect with you there, and they can probably also message you there as well.
Absolutely. I do read my LinkedIn.
Me too. It's actually, I feel like it's become one of the, like, I don't know, most active social networks, or I don't know if it's just my circle, but it's a great place to be on right now.
I don't know, Sage, maybe it's just because we're getting older and that's like the one social network that like seems to hold true. Yeah. It's funny. I just continue to believe that there are other social networks. I'm not aware of them.
That could very well be it. But with that, we'll go ahead and I think wrap up the stream. Thank you so much, Rajat, for coming on. Thank you everyone for attending. I know I saw quite a few viewers in here, and if you have questions later, go join that Slack channel or connect with Rajat on LinkedIn and ask them there.
Yep. Thanks so much, Sage. I appreciate it.
Thank you. I'm going to hit end on the live stream. So we'll